Welcome to my channel Phi Concepts CHM. This is the fourth part of the series of band theory of solids, where we will see about Brillouin zones. Brillouin zones. The electron moving in a periodic potential have energy values lying between the allowed regions, which can be called as zones. We will plot the E versus K graph from the previous derivation equation 14. P sin alpha A upon alpha A plus cos alpha A is equal to cos Ka. Cos Ka is equal to plus minus 1 for the values of K as n pi. So from this we get K as n pi by A. So the RHS of this equation has values between plus 1 and minus 1 for K is equal to n pi by A. So when we plot the graph of E versus K, there will be discontinuities in the graph which will occur at K is equal to n pi by A. For n is equal to plus minus 1, plus minus 2, plus minus 3, so on. So this is the graph of E versus K. These are the curves, these solid curves on both sides of the y-axis. First Brillouin zone lies between minus pi by A and plus pi by A. Second Brillouin zone lies between 2 pi by A and minus pi by A, and on this side between pi by A and 2 pi by A, and so on. The dotted curve that we saw is for a free electron. Okay, it is a parabola with energy given as E is equal to h cross square k square by 2m, which is purely kinetic. The electron has allowed energy values in the region k is equal to minus pi by A to plus pi by A, which is the first Brillouin zone. Then comes the forbidden region. The second Brillouin zone has energy values lying between k is equal to minus pi by A to minus 2 pi by A, or between k is equal to pi by A to 2 pi by A. Similarly, there are higher order Brillouin zones. Now K has different values in different directions. Consider a motion of electron in a field of two-dimensional square lattice. K has two components along x and y axis, that is kx and ky. To sketch the first Brillouin zone, K will have values plus minus pi by A in x direction and plus minus pi by A in y direction. So K is equal to plus minus n pi by A. In two dimension, we can write as K suffix x n1 plus K suffix y n2 is equal to pi by A into n1 square plus n2 square, where n1 and n2 are integers referring to each axis. So to sketch the first Brillouin zone, we have to put n1 is equal to plus minus 1, n2 is equal to 0, in equation number 2. So you get kx is equal to plus minus pi by a, and then n1 is equal to 0 and n2 is equal to plus minus 1. So that ky is equal to plus minus pi by a. Using this we can sketch. You can see the first Brillouin zone is this box shaded in the slanting lines. It will cut at plus pi by a and minus pi by a on the kx axis, and at plus pi by a and minus pi by a on the y axis. So the first Brillouin zone passes through A, B, C, D. Second Brillouin zone will pass through E, F, G, H, which can be obtained by taking n1 is equal to plus minus 1 and n2 is equal to plus minus 1 in turn. That is in this form. First we will take n1 is equal to plus 1, n2 is equal to plus 1. So you get kx plus ky is equal to 2 pi by a. Then n1 is equal to minus 1, n2 is equal to plus 1. So that will give the as minus kx plus ky is equal to 2 pi by a. Then taking n1 is equal to plus 1 and n2 is equal to minus 1, we get kx minus ky as 2 pi by a. And n1 is equal to minus 1 and n2 is equal to minus 1, we get minus kx minus ky is equal to 2 pi by a. The third Brillouin zone is obtained by giving values 0, plus minus 1, plus minus 2 to n1 and n2. The equation 2 in 3 dimensions will become kxn1 plus kyn2 plus kzn3 is equal to pi by a into n1 square plus n2 square plus n3 square. Thank you for watching this video.